All right, you got any problems written down? Oh my gosh. You got any problems written down? Guys, we're wasting review time. You got some? Thank you, Miss Plummer. All right, so I am changing up the problem a little bit because some of these we
I don't know. You are someone else?
had done already.
I found a calculator owner.
Oh,
Borrowed
good.
it from someone else. I knew once I actually did something with it, they would all be crying.
All right, so we want
There
to
we go.
find the cosecant of, let's say 5 pi over 6. All right, you are going to have a problem like this on your test. One problem where you're going to have to, it may not be a cosecant, it'll be something, tangent, whatever, and you have to find the exact value of it. So this is a no calculator problem. I've told you what your test looks like, right? White page, front and back, colored page, front and back. Samaya, how nice of you to join us. This is gonna be on the white page, no calculator. So, anybody remember how we start, what we do first? Well, there are a couple things you can do. First of all, I would change that into degrees if it were me, remembering that pi is 180, and 180 divided by 6 is 30, and 5 times 30 is 150. So this is the cosecant of 150 degrees. 5 times 180 divided by 6. So then I'm going to draw 150 using my standard labels. Here's 150. And I'm going to make a triangle. I'm going to drop that perpendicular straight down. Now, use your common sense. How big is that angle right there? 30. Now, I don't have the reference sheet up there, but you saw it the other day, and it does have the 30, 60, 90 triangle on it. Hopefully you have that memorized, but if you don't, it is on the reference sheet. So remember, something's negative though. What's negative?
Negative square
The
root.
degree's gotta be negative because of where we are located. And then cosecant is also on the reference sheet. Cosecant is the reciprocal of the sine, which is hypotenuse. Sine is opposite over hypotenuse. That's on the reference sheet too. But you want the reciprocal of that, so you're going to do hypotenuse over opposite, which is 2 over 1. So the answer to this problem is just 2. All right, and then she wants to write, let's say 0.3, this as a fraction. So, what I would suggest you do is think of it as its individual digits. So 0.34444, so you have 0.3, then 0.04, 0.004, and so on. This guy's kind of an odd wad, but there's a definite pattern to all of this. Right? In fact, it's geometric, infinite, so we're going to use this formula, which is also on your sheet. So we're going to take our first term. Now, this is not the first term because it's different. So we're starting here. So 0.04 over 1 minus the ratio. Now, what's the ratio here? Who remembers?
0.01.
0.1. Why is it 0.1? Because how many digits are actually repeating? 1. 4 is the only repeating digit. So when there's one repeating digit, it's 0.1. So we have 0.04 over 0.9, which is indeed a fraction, and that was the job of this problem, was to change it into a fraction. But it's got decimals in it, and it's not allowed to have decimal points in it. So we're gonna get rid of those decimal points by moving them a couple of places, and that's gonna end up as what? 4/90? Now hang on to that for a second. That's this part. So now we have to take our 4/90 and add it to that original 3/10, which we had to take off because he wasn't part of the repeating part. So your common denominator. We have 4/90 plus 27/90, that is 31/90. And that's your fraction, 31/90. All right, thank you, Plummer. Who else has a piece of paper? Plummer. Here we got some. Here's some, okay. I'll give you your papers back in case you, give them more. Okay. Couldn't quite figure out what you were talking about here, Olivia, but now I've got it.
Trying to be free.
I've got it. So she wants to, if we have an equation like -3 sine 5x, she wants to find the amplitude and the period, which is gonna happen on your exam. Different equation probably, but the same thing. Okay, who remembers? We did this the other day. Someone has to remember. Amplitude is 3. This number refers to the height of the wave, so that number is 3. Positive, I know it's negative, but amplitude is always positive. And then remember, if we sketched this, it would be an upside down sine curve. Its height would be 3. You do not have to sketch on your exam. But if we did, that's what it would look like. And what are these labels supposed to be? 90, 180, 270, and 360. But what's happened?
Divided
We divided by that number, which means that our period isn't 360 anymore. Now it is 72 degrees. 360 divided by 5. Okay? This is super simple. What do you have to remember? That number is the amplitude. This number divides 360. That's what you remember. All right? Olivia also says she wants to talk about a 5-card hand and find the probability of, I don't know, let's say no more than 1 queen. Okay? So what's going through your mind now? We want to find the probability of no more than 1 queen in a 5-card hand. 52C5 is my denominator. Whatever is happening in the numerator, 52C5 is the denominator because there are 52 cards and I'm picking 5 of them. Alright, now the numerator is what I want. Okay, so what do I want? Okay, so 1 queen. Well, how many queens are in the deck? 4, and I'm going to pick 1 of them. But remember, it's a 5-card hand. So if 1 of them is a queen, what are the other 4?
48C4.
Not queens. 48C4. So this is a 5-card hand. 1 is a queen. The other 4 are something other than queens. And there are 48 cards that aren't queens. Okay, now wait. I've got this not centered because what else could happen in this problem?
No queens.
No more than 1 queen means you could have none. So that would be 48C5. technically, if you wanted to put in 4C0 and then 48C5, that means you want 0 queens and 5 non-queens. And it's 1 queen or no queens, which means what goes right here?
Addition.
An addition. Yep, exactly right. If the problem had said, what's the probability of getting exactly 1 queen, then it would just be this part right here. Exactly 1. But since it said more than 1, we had to consider none also. All right, and then one more for Olivia here. She says we got a couple of matrices, and we gotta multiply them. So matrix A is 1, -2, 3, 5, and matrix B is -2, 0, 1, -1, 5, 0, 7. Okay, and we're gonna multiply them. We're gonna find A times B. What's the first thing we have to check? Can you even do it? Yeah, so this one's 2 by 2, 2 rows, 2 columns. This one's 2 by 3, 2 rows, 3 columns. Can we do it? Yes. And our answer will be another 2 by 3. So in other words, it's gonna look just like that one. So I gotta find all these numbers that go in those spots. So who remembers how we do that? How do we do that?
Rows and columns.
We take always the row first times the column. So that spot right there is gonna be row 1, column 1. So I write down row 1. And then next to those numbers, I write down column 1. Multiply each pair and add them up. It looks like -12. And then I move over. So row 1, column 2 is all zeros. So that's just gonna give me a 0. Right? And then go ahead and keep going while I check something real quick. You guys can go ahead and fill in the rest. Did you get -15 for this one?
Yes.
And, 19, 0, and 32. All right, tell me what I missed. Did I miss any of those, or do you match all those? All right, so Olivia, you good on that? That takes care of Olivia.
Thank you.
Okay. Now. This is Quinn's. Your first one, Quinn, is not on the exam, so I am actually not gonna do that if that's okay, but I'll do one that is on the exam. We already, well, no, I think that was in the last class I did, so I'll do one of these. You're gonna have to simplify a trigonometric, expression. Alright, so we're gonna simplify this. Now remember, on your, reference sheet, a lot of this is on there, not that problem, but a lot of the definitions. So in other words, on the sheet, you will see that tangent is sine over cosine. So then you need to just remember cotangent is cosine over sine. Secant is 1 over cosine, and tangent is sine over cosine. So your reference sheet has that on it, I think, pretty much. Yeah. Okay, so then what? Then we gotta start canceling anything that cancels. So cosine on the bottom is gonna cancel cosine squared on the top. And oh gosh, I have two sines on the top that'll cancel with two sines on the bottom, so that one works out just to be one because everything cancels. Alright, and then Quinn's got a matrix problem similar to this one, except he wants to add them. So I'm gonna use that matrix A, and I'm gonna give you a different matrix C here. I can't just use my original two, because if I'm doing an add problem, they don't add. So I'm gonna have to set up a different one. So I'm using that matrix A, this matrix C, and let's do 2A minus 3C. Okay? Call me my friend. I have the power to have you take the exam, which I will do if you don't stay focused and pay attention. Alright? This is a regular class for you, and I expect you to behave like a regular student. Alright? Thank you. Alright, so 2A minus 3C, what am I gonna do? Multiply 2 times A, so that's like distributive. Just take 2 times all of those things. And then I'm gonna take 3 times C. Now that's not negative 3, that's minus 3 times C. So I'm gonna take 3 times that. Oh. 3 times that. And now I will subtract them. Is everyone paying attention here? Okay, so here we go. Giovanni, same goes for you, sweetie. I need you to pay attention. I need you to be writing down, being engaged. All right, so 2 minus 9 is negative 7. Negative 4 minus 15 is negative 19. 6 minus 6 is 0, and 10 minus 3 is 7. Twins, that make sense to you? Alright, and then another one you put on there isn't exactly on it as you wrote it, so I'm going to modify that a little bit too. This will be a calculator problem. And we're going to have to find the area of these triangles. So we've got that triangle, and then we've got this triangle. And we're gonna find, we absolutely positively are gonna have to find the area of these triangles, okay? Now, there are 2 area formulas on the reference sheet, and one of them is that big radical thing, remember? We call it Hero's formula. What do we need to know? The formula is written down, but it doesn't do any good if you don't know what all those things mean. What do we need to find to use Hero's formula?
A pair.
That's law of signs.
That's all sorts.
That's law of signs. To do Hero's formula, we need the perimeter. What's the perimeter? I'm doing this one first. What's the perimeter of this guy? 50, 32, 52? And then we need half of that, which is
26.
26. So in the formula goes a 26, the semi-perimeter. Then there are 3 other things that go in the formula. What are those?
Semi-perimeter minus each side.
This minus each side. So don't put those sides in there. It's 26 minus 20, 26 minus 15, and 26 minus 17. And then we type all those, multiply all those. This is definitely a calculator problem. And then square root it. Remember, you're taking the square root. So the area of this triangle is 124.27. So make sure, as you're studying, that you're going back through and typing all these in and getting the same answer. Now, this is the same problem, find the area. Will that strategy work for that one? No, because there's no way to find the perimeter because I don't know the missing side. Anybody remember that formula? It's on your paper, but it's all in terms of letters, so you have to kind of know what you're doing. What do? Take area is?
For this one, it would be 17 times 19, sine 62.
That's half of that. So it's 1/2 side times sine of included angle. 1/2 side sine. So she said take 1/2 17, 19 sine 62. No square rooting there, just type it in. And that's 142.6. Would be the area of that guy. Okay? Alright, those are good problems. Who else has a sheet for me? That's yours. That's yours. I
Well,
know
Mel
this
has
is for-
some too.
Mel has some good.
We already did
Alright,
one,
so
but-
you start, you already do one of those?
Yeah.
Alright, so her problems, and she has taken them, from the sheet, because I remember what they look like, so I'm gonna just change the numbers a little bit. So she says, solve this equation. This is a no calculator problem. How do we solve that equation? Loop-de-loop. So it's gonna be 5 to the negative second equals x. Now, this one's a little tricky, gotta have another skill. What does 5 to the negative second mean? 1/5 squared. So your answer is 1/25. Now, if there's partial credit on this test, I'd like you to get that all the way to the end. That's easy enough, but if you started with this, you're gonna get partial credit for that, because that's what it is. 5 to the negative second equals x. And she says 500 degrees is how many radians? Now, there are different versions of the exam, of course. Somebody's gonna have that question, and somebody's gonna have, I don't know, 4 pi over 3 radians equals how many degrees? So these problems are basically the same but backwards of each other. So anybody remember how to do either one of them? Most people find this one the easiest because pi is 180. So you have 4 times 180 divided by 3. So 3 goes into 180, 60. I think this one's 240 degrees.
Yep.
Okay? This one you do exactly the same way. Use exactly the same idea. Pi is 180.
Proportion.
So what is 500? That's the question. If pi is 180 degrees, then what is 500 degrees? Okay? And then we'll cross multiply. And we have 500 pi over 180, which these always reduce somehow. What is that, 25 pi over 9? I can cross out the zeros and take out the 2. Okay, Melissa? Then she's got a calculator problem. calculator problem is something like 7 to the x equals 19. Now, if that were 7 to the x equals 49, I wouldn't even need a calculator, right? Because 7 squared is 49. But there's no like whole number power that I can take 7 to get 19. This is a calculator problem. Who remembers what we have to do? Log both sides. And the reason we log both sides is because this guy can immediately come out in front. And then what happens? We're solving for x, so we just divide. So our answer is going to be log 19 divided by log 7. 1.513. Alright, and then she wants to do another card problem. So let's say we have a 5-card hand. And you want to know what's the probability of exactly 3 clubs. What's our denominator?
50 plus 25.
Yeah. Everybody ought to get partial credit just from that, right? 52C5 is your denominator. Now what goes on top if we want exactly 3 clubs? 13C3 will take care of the clubs because there's 13 clubs in the deck, and we have to have 3 of them. We have to have 3 of those 13 cards. But don't stop here, because right now, how many cards are in my hand? 3. I still have to pick 2 more. And where are they coming from?
Anything other than
The
clubs.
rest, anything not a club, which would be a heart, a diamond, or a spade. So 39C2. And that's a multiply because I want 3 clubs and 2 something else. Alright, I haven't typed one of those in yet, so I'm gonna go ahead and type that one in, just so you can practice and know that you're getting the right number. Hopefully, I'm getting the right number. When you go back and hopefully study,
082.
when do we take this thing?
Thursday.
Not till Thursday?
Yep.
Alright, I got .0815. I hope that's right. Okay? Alright, so that takes care of Melissa's. Alright, now I got one more for, ooh, I can't just make these up.
I get the one that she can't pick up.
Yeah. You gotta plan, some of these things have to be planned.
Mr. Jamel and Mr. Breshka. He said he'd sign anything else and I wasn't risking my time in case.
Alright, so she wants a partial fractions problem. Oh, time out, wait. We don't do partial fractions in this class.
We
We
don't?
never did those, no, so never mind that.
I was wondering why we didn't.
I planned one, but, I mean, we do it in academic and honors, but we don't do it in CP, so, yeah, no partial fractions. Don't have to worry about that one. Alright, who else has problems written down for me?
I got one.
Okay, I already did one of these, but I'll do another one. So we have to simplify. Oh, let's say secant squared tangent, cosine squared, sine. Alright, so we're gonna simplify this. So what do? We change everything into sines and cosines. And that means everything's gonna be a fraction. So secant squared is 1 over cosine squared. Tangent is sine over cosine. Cosine squared is already cosine squared. So we just put it over 1 to keep everything lined up, and sine. And then we look around to see if anything cancels. Looks like these guys will cancel. I think that's it. So I've got sine squared on the top and cosine on the bottom. That's it. All right. Who else has problems we need to do? Who has something else written down? Okay, yeah. So the problem is something like 16, 1.04 to the x. And the problem says, number with this, several parts to this question. First question is it growth or decay? Growth, because this number is more than 1. What is the percent growth or decay? 4% growth. Because when you find your percent, it's how much more you are than 1 or how much less you are than 1. So if this problem had been this, that would be 4% decay. Okay? This actual number is never your percent. It's how much more than 1 it is or how much less than 1 it is. And then the last question in that set is, what's the initial value? So these are population things, equations. What did you start with in the beginning? How many people, how much money? What was your initial value that you started with? 16. There's really no math to do in that problem. You just need to remember what everything is in the equation. All right, what else? Okay, this table has given me nothing. Not on the exam. You need to focus on the ones we did in class the other day. So I can't remember which sheet that was, but those are the ones that we're gonna have to do. Now, for sure, Simone. Or what? Yep. Okay, I'm not gonna do these exact numbers because it won't work out very well. But yes, we can simplify. Let's say we have 27 instead of 4. Y to the negative third over 8. X to the negative second. Y to the 6th. I'm gonna raise that to the 1/3 power. All right, what do we need to do? It's a simplify. No calculator. Don't need a calculator. We're simplifying. What are we gonna do?
Distribute
Distribute the 1/3 to everything? You know what? Yes, I can do that, Jacob. This is a mess in here. I think I'm gonna clean that up first. So that I don't have as much to distribute. So I mean, obviously my 27 by 8, nothing happens. What happens here with the x's?
The second goes
These go up. So I've got 4, I bring up 2, that's gonna give me x to the 6th. And then these come down, so I'm gonna have y to the 9th. We can do what you said, that is exactly fine. It's just easier for me dealing with the fraction, especially if we clean this up first. Now I'm gonna take everything to the 1/3 power. So that means 27 to the 1/3. That does not mean 27 times a third. That means 27 to the 1/3 power. What do I do with these exponents? When I already have next to the 6, and now I got a 1/3, what do I do with those? Multiplies, that's gonna be squared. 8 to the 1/3, and y to the 3rd. So these exponents, the exponents get multiplied. So the numbers, I have to actually power them. So what does 27 to the 1/3 mean?
It's 3.
27 to the 1/3 means the cube root of 27. So what's the cube root of 27? 3. What is 8 to the 1/3 mean? Cube root of 8, which is 2. So that would be my final answer. So we have to remember there that numbers get the powers, exponents get times by the powers. So that's a multiplication right there. Okay? All right, what else do we have? Oh, now, yes, for the exam, let's see, the problems are like, find the center and the radius for x squared plus y squared minus 10x plus 4y equals 17. Alright, so what do we have to do to find the center and the radius?
Group the x's and multiply.
Yep, I'm gonna do some grouping here, so x squared minus 10x plus something, y squared plus 4y plus something equals 17, plus those somethings. Okay, so then we complete the square.
5 by 2 squared.
Yep, so 10 divided by 2 is 5, squared is 25. 4 divided by 2 is 2, squared is 4. So here we go. These make what? X minus 5 squared. These make what? And then all that gets added up to make 46. Check that arithmetic. So where's my center?
5, negative 2.
Alright, negative 2, and what's my radius? Root 46. So some test is going to have that one. Another test is going to have, in terms of the chapter that we just did, no. X minus 3 squared over 81 minus y plus 1 squared over 16 is 1. This is a hyperbola. What is the slope of the asymptotes? What is the slope of the asymptotes of that hyperbola?
4, 9.
So the plus or minus, first of all, just remember how one's positive and one's negative.
4 over 9.
4 over 9. Why is it 4 over 9? You don't have to draw it all out, but you can. But what would this 16 tell you?
Up 4.
To count up 4, and that tells you to go over 9, and that's slope, up over over, that's it. So plus or minus 4 9 is it. Another question that can come out of this same hyperbola is, where are the vertices? Now, you don't need to get all fancy and whatever in your graph. You can, you get as fancy as you want. But you have your center at 3, -1, right? And that right there tells me to count sideways 9. And aren't those gonna be my vertices? Because don't my vertices go with the letter that comes first in the equation? So these would be the vertices right here. So if we counted 9 forward, that would be 12, -1, and 9 backward, -6, -1. Okay? Alright. Okay, what else? Anything else? Got a few more minutes, guys.
You do a cosecant, probably,
Like what?
like cosecant of 8 pi.
I did a cosecant, let's do a secant this time. So we'll do the secant of 7 pi over 6. So the first thing you'll do is change that into degrees, which could be another exam question. I mean, that could be an exam question all by itself, is how many degrees is that? So remember, pi is 180. 180 divided by 6 is 30, and 30 times 7 is 210. Now, I don't care how you get 210. If you want to do 7 times 180 and then divide by 6, that's fine. Somehow get 210. Draw 210. Using your standard position labels, this would be 210. This is the angle in question. How big is it? Oh, guys, come on. That's gotta be 30. If this is 180, aren't we going 30 past it? And then your reference sheet will have these on it if you don't already have them memorized. But you are gonna have to remember to put in the negatives. So what's negative in this one?
2 and root 3.
The 2 is never negative. Remember, the hypotenuse is
hypotenuse,
never
yeah.
negative. Hypotenuse is never negative. But x and y, horizontal and vertical, can be negative, and they're both negative in this problem because of where we are. Okay, then what's secant? Well, your reference sheet's gonna have down there, it's gonna say secant is hypotenuse over adjacent. So if you've forgotten what secant is, you can look on your reference sheet, and hypotenuse over adjacent will be 2 over negative root 3, which is negative 2 root 3 over 3 when I rationalize. Now, that could be a tangent or a cosine. I mean, that could be anything, and you're going to do the problem exactly the same way. Just end up with a different fraction as your answer. All right? What have we not done that we need to do?
You could do one with Pascal.
This calculator problem, find x.
1/2, 17, 16.
Now, 1/2, 17/16 sine 53 is area. You're exactly right. That looks just exactly like the area problem. But this is not area. This is find a side.
So log sign.
It's a law sines or law cosines, because that's how we find sides. That's it. Those are your options. Now, how do we do the law sines? What do we have to do the law sines? We have to have a pair. Now, I want you to look at this. Do I have a pair? No, I don't. That's an X. I do not have a pair. I don't have that angle, I don't have that angle. This is not gonna be a law of sines. This is gonna be a law of cosines. Okay? The law of cosines will be on your reference sheet. But it's not gonna have an X in it, it's gonna have a bunch of letters in it. So you need to remember that the law of cosines says x squared, 16 squared plus 17 squared minus 2 times 16 times 17 times cosine 53. You know, practice these things, guys. Practice them. You know exactly whose that is because she washed my razors for me, so now hair got in it. All right, now I'm going to type this in on my calculator. And this problem, and I know some of you are so sick of me reminding you of this stuff, but this problem you have got to remember to take the square root, because when you type all that in, which is easy, just type it all in, but you're gonna get x squared, so you gotta square root it. And get 14.75. All right, and then a couple real easy ones, or should be easy ones. All right, so what's the limit up here? The limit is 4/6 or 2/3, right here, n squared over n squared. Same as the horizontal asymptote, if you had functions that you were dealing with. All right, what's the limit here? 0. Why is the limit 0? Because that number right there, this is where my beady little eyes are focused, this number right here is less than 1. If I turn this upside down and made this a 3/2, then there would be no limit. Because if that number is bigger than 1, there's no limit. The terms are getting bigger and bigger and bigger instead of smaller and smaller. All right, okay, that's it. We have class again tomorrow?
No. Oh, yes.
Yeah.
Yes, we do.
Okay, we have